Hello everyone. Today I thought of making another tutorial but showing all the process from start to finish, from getting the footage you recorded in your camera to have the motion in 3D space inside Blender. So let's start. First thing to do, I'm gonna download the image from the camera. Let me plug it on the PC just a bit. This is the camera one. Let's see here. What I like to do is to rename the file inside the camera, so when I move I already know which camera it is and don't have problems to find which one it is. So here I'm gonna rename it to cam01, and I'm gonna copy it to a place where I save my videos. This is from yesterday in the folder. And this is the raw file that I recorded yesterday. Here it was copied, so let me move. Now I'm gonna upload the second camera. I said I was not gonna pause, but I had to pause because I had an unexpected behavior. There was no energy on the camera, so I couldn't turn it on. But I fixed it. Now I'm gonna rename the second camera file. And copy it to my local drive. Videos and sitting. After copying the files, what I do is to sync them inside Blender. I'll use Blender to sync the files. I have them here already. Let's go, let me hide this and get to the side. I'll go to File, New, Video Editing, and I'm gonna pick the video file here. I'm gonna erase this green stripe because it's the audio and I'm not gonna use it. Get the second camera and also erase the green stripe. So here we have cam 1, cam 2. What I do is select the second camera. I'm gonna hide it because I want to find a place in the first camera where I can use to sync them. Usually I do some sort of releasing shoes to make the sync like this. You can see here I pick up my shoe, and at this point I'm gonna place a marker using the letter M, so I have it marked, and I'm gonna go to the second video. I'll press Alt H to unhide, and I'm gonna press the G button and I'll move it to the side. You can see here the stripe is moving to the side, so I'll move it using my directional keys. I forgot the name. For the left, so I can find where my shoes fell on the floor. And you can see here it's the moment that gets in sync with the first camera. So what I do now, I'll press, I see here, show seconds. I uncheck show seconds so I can see the frames. What I'm gonna do is use this. Let me see just a moment. I would like to, okay, I'll get this part here. 584, I'm gonna round up to 600. Okay, so I'll select both stripes, press G, 600 minus. So the beginning of the recording is gonna be that moment that I showed before. And the full scene is gonna be until this place. I'll press Ctrl End, so it selects the end of the video, or I can go over here and write it by hand, but I don't like this way. Okay, now I'm gonna hide this second camera to export the first one that I synced and crop it. What I'm gonna do first, I'm gonna see if the resolution to render is the same resolution of my video. In this case, my video has, let me check, source, it's 1920 1080. That's exactly this. So now I'm gonna choose the file to export it, which is gonna be the same file folder that I pasted the camera files. I'm gonna create a new folder, call it sync, because I'm gonna know that it's already in sync. It's camera 001. Accept it, and I'm gonna change it to FFmpeg video and change to H264 in MP4. Now I can render the animation. first camera was exported. So now I'm gonna hide the first one, select the second one, unhide the second one, and change the name here to C02, and I'm gonna render it too. So this is the second camera that is synced with the first one. So the second video is exported. Fine, that's great. But for this, the purpose of showing the full workflow, I'm gonna do another thing. I'm gonna make a shorter version so we can have a faster processing. And I'm gonna cut around here. It's gonna be the end, and here it's gonna be the start. So I have only this part. It's around, let me show, put a smaller one, just about 100 frames. So what we're gonna process is this movement. Fine. So what I'm gonna do, same thing, I'll hide the second camera. I'm gonna show the first one, choose another photo here. That one was sync, and this one I'm gonna name short because it's the one we are going to work, so we don't take 2 hours to render this. I'm exaggerating, but just not to take too long, because the explanation it's going already to be long. Okay, camera 1 and render. Great. Now hide the first, select the second one, unhide the second one, change the name, and render. Okay, great. I think this part can be the most complicated for most people. So let's go to the add-on itself to do most of the job. Select a new one, don't need to save. Go to the tab folder. Now I'm gonna create a project from scratch to show all the process. So I'm gonna create, there are 2 cameras, resolution 1080 and FPS is 60. I'm gonna put a custom name is sitting, so I don't mess up with the other ones that I already have. New setup. Now I have the new setup. Great, I can go to the project data and select this one that I just created. Must choose the folder that I'm gonna use to save this file, and I'm gonna create for this project, it's gonna be 10 because I'm ordering the process that I'm doing. I already have 9 folder, so it's gonna be a 2 camera. setting example. Select that and save the file. We have a menu showing the 3 steps that we have to do. We are already in the first one, the intrinsic. And what do we have to do? Select the camera one, press here select, and we are going to need something I didn't show, but I already have here, the video calibration for each camera. As far as I remember, is here Intrinsic Calibration. I have the video for my first that I already recorded in the past. I'll choose the first one, select it, save. Select the second one, press select, and choose the second video and save. If you want to add a description, there is an option here for you to do that, but you don't need it if you don't want. This option is to save the video in the project folder. So if you find interesting to have everything in one place, you can use that button to have it. Just let me show. We have the folder with the project we are just set. If I press save video, it's going to create an intrinsic folder with the video or the intrinsic calibration. We don't need that. For this part it doesn't need, so I'm gonna erase it to be simpler. And okay, let's go to the frame selections. Now you split the screen, just grab this lower part and push to the side and press 3D to VSE. Select the first camera, load on VSE. Now you have that video we just selected here, and pressing the letter M for marker, you are going to select the places where the chessboard reaches the corners of the camera. So here I have the one corner here, press M to select it. Another corner, press M. Let me press home to show all the video. Another corner, press M, and another corner, press M. I think that's enough. Press render, and it's done. He created a folder with the image that we just selected. Those 4 images are here. That's great. Now let's go to the camera 2. Load on VSE, and let me go to the beginning. The first corner, press M. Second corner, third, fourth. Let me get another one here. No, that's fine. And render frames. Just created another folder for the second camera. And let me see. Here you have to choose the particularity of the chessboard. In this case, my chessboard is 3 by 5. There are points of intersection. You can see here 1, 2, 3 points. 1, 2, 3, 4, 5 points. So we have to put that pattern here, and this is the size in meters of the square. You gotta measure it and put the size here. Now we're gonna press detect chessboard. It takes a little bit, which made me remember it's very interesting for you to go to the window and press the show console so you can know what the add-on is doing behind the screen. Let it finish the detection, and I'm gonna open the console that I always forget to open. So let's see here. System console. Great. Let me do this to be better to watch. So it detected the chessboard. Now we're gonna calibrate it. We did the calibration. That's very important to save it in the profile. So the intrinsic calibration is gonna be saved on this folder that we created. Now this intrinsic part is finished. can go to the next part, which is the extrinsic. You go here to select the cameras. In this case, I'm gonna select, no, not here. It's my original video, the sitting one, and I'm gonna pick the raw video. I don't need to pick, I'm gonna pick the raw video because I'm sure this raw video has the chessboard. We need the chessboard inside the scene that we recorded to make the extrinsic calibration. Camera 2, save it. This save video is the same thing on the intrinsic video. You don't need to save the extrinsic video on your folder, but you can do if you want. I'm not gonna do it. We already have the VSE open here, so we just need to go to the camera 1, load on VSE. I'm gonna clear the markers because I'm gonna need just a frame to show the chessboard. I'll press M here to select this frame and render frame. Great. Now we go to the camera 2, load it. Let me clear the frames, and I'm gonna select this frame, press M, and render frames. Great. Now that you render it, you can press detect chessboard. It's doing the detection on both frames. We already finished. You can press calibration. We calibrated, but we gotta see if it did it correctly. Sometimes it can't see the chessboard and we have to do it manually. We can check this pressing check cross and check cube. You can see that it detected very well on the first and on the second camera. And we press check cube to see if it makes sense in reference to the chessboard. Seems it makes sense. And this one, it's a little odd. Maybe this one doesn't make sense. We'll see. One important thing, in case the calibration doesn't go well, we can fix the camera manually. Let me show how to do that. We need to have Python installed. In my case, I use Conda. I already have a virtual environment with this package installed. That's it, because of it I wrote Conda activate EMB3, because LabelMe is installed on that virtual environment. But okay, you install LabelMe, writing pip install LabelMe, and let me show. I opened, but I didn't show how to install. Having Python installed, you write pip install and install LabelMe. Doing that, pip is going to install it, and after installing, you just write LabelMe and it's going to open. I like to use the open there. Let me go to the project folder, which is Mocap Test 10 Extrinsic Images, and we have to select the one that we find more important to change. The first one looked nice for me, but the second one was a little bit weird, so I'm gonna fix it. I'm gonna open it, open the folder, select the folder, and the image is gonna show. What I like to do is do a good zoom and place the chessboard in the center. Then I press create polygons, and let me see one thing first. The check cube. we can see that the point 0 is here down below, so we have to create the polygon starting from here. We're gonna create the first point, second, third, fourth, fifth, and so on. So let's see. Go back to label me, create polygons, and start from here. You just click in the intersections of the squares. No, I by mistake press it twice. And press enter, put any name you want, and save. You just save in this place, the place that it suggests, that in the same folder of the image file. No problem, save here. By the way, it's important to save here so you can use what is prepared inside the add-on. In the add-on, we have this fixed JSON already setting the place of the origin and the correct JSON that is the one that we just saved. So we corrected the second camera. We put second camera here and press fix JSON, and then press calibration again, so it can calibrate once more. Now we check again the cross and the cube. Cross looks fine, and the cube, the first one was already fine. The second one is a little bit odd, but you can see that it starts in the same point. You have to see how it goes. So let's go to the last part. Here is where I'm going to make the pose estimation, use OpenPose, and do the final triangulation. Now what we're going to do is select the final camera, the synced video file, but to not lose too many time, I'm gonna select the short one that we've created. If you're going to do the full thing, you can select the synced one. I'm not gonna use the synced one because it's going to take much longer. I'm gonna go to my folders video, setting, short, camera one, save it, select the second camera, and do the same, save it. This is important to save the video on your folder, so press it. Now here you select where you have the OpenPose installed. To install OpenPose, it's not really installing OpenPose. You go to the GitHub of OpenPose Conceptual Computing Lab, go to the release folder, here, release folder, press here, 14 releases. What I found that worked best for me was not the latest one, but the 1.6. You get this, you're certainly using Windows, I guess. You can choose the GPU version, in my case I have GPU, or the CPU version, which takes too much to process. If you have a GPU, NVIDIA GPU, you can choose this one. If you don't have, you have to choose the CPU version. So download it and extract it in some folder you have. In my case, I have it not in this drive, it's this one. I have it here where you are. OpenPose. I have several versions. What I found that worked best was this 1.6. So you unzip it, just unzip it, and I think you have. Sorry, I forgot this part, but I think you have to run a bot that comes within it. Sorry, this part I don't remember, but there are explanations on the site about it. Let's go back to Blender. So you select where you have your OpenPose, which I have here. I'm gonna select the 1.6 and OpenPose path. Here you can select the option to detect the hands and face. I'm not gonna do that because it will take much longer. And this one to render the image showing the pose that OpenPose finds. I won't press it because it takes much longer to finish. And I'll click Extract Run. So it begins to create. First, it's going to create the image sequence from the video, and after that it's going to start processing using OpenPose. That's what it's doing now. It created the image sequence, now it's creating the pose estimation. Finished for the first one. After he finished the OpenPose part, he runs the annotation from Easymocap. That's gonna be stored in this annotations file. It's finishing the second video and it's done. So now we have all the data necessary to do the triangulation. After that, we need to have a SMPL model to process. To do that, you gotta go to the Simplify homepage that you have the link on the download page from the CEB Easymocap add-on. Go to download folder. You need to sign up to download it. Go to download folder and download this option here, Simplify Code V2 zip. When you download it, it's going to show as mpips Simplify Public V2. You open this file, open this folder, open code, model, and then you have this basic model neutral LBS PKL, which is here. I already extracted. You're gonna need this file. So you go back to Blender, choose, you only have this option now. In the future I may add the male and the female option. So you go to the import, go to the folder you have, which is here in my case, select it, and it's copied to the add-on folder. You don't need to do this part anymore. Now we're going to the triangulation. If you have more than 2 cameras, you can select less than all the cameras you have. For example, let's say you have 4 cameras. You did recording using 4 cameras. You want to test just the first and second camera. You can do this, press 1, comma 2, and process with this. It's going to process only these 2 cameras. If you want to select other amount, 1, 2, and 3, you can do it like this. But I just have 2 cameras, I won't do the custom camera option. If you have a problem on the processing, or you just want to do a test, you can select less amount of frame of the full video. You can, let's say you have a video with 3000 frames, but you just want to test with 100 frames. You can put here the start frame from 0 to 100, for example, and triangulate like this. But I'm not gonna do this unless we get an error. And if we get an error, sometimes it's interesting to use the start and end frame to find where is the problem. But I'm gonna use this render raw point data and render triangulate point data, because this option, it's going to create an image with the point on the image where the triangulation, where the pose estimation is, which helps us a lot to find problems. Okay, now I'll press triangulate, and it's going to process. Let me go to the folder of the project. You can see it created the folder output, where we have some folders here. This detect folder is the first image that it creates with points. I think it's from each of the camera. After that, it's going to triangulate and process and create a set of images using the both cameras together. So sometimes the image on detect looks fine, but the image on repro doesn't look too good. And usually it's a problem of extrinsic calibration. It's still processing, but we already can take a look at some results. One important thing here, you can see this part, it's not, it doesn't look fine. This is because of the intrinsic calibration. I didn't do the best intrinsic calibration. I should choose more frames to calibrate it, so this distortion wouldn't happen. I'll see if I redo this intrinsic calibration to show that this distortion can disappear. So you can see here it looks quite fine. The placement of the lines look to be very well on the body. Let's see the other one, the repro SMPL. Here it doesn't look too good. Maybe we are going to have problems. Well, the triangulation finished. What we are going to do, we are going to go to the first, let me save this file, because maybe it will be interesting for us to get back to this setup that we already done. We'll save on the same folder of the project. Okay, now I'm gonna clean the scene to get the triangulated data and import it as a 3D motion. Okay, now what we have to do is use the Mocap Import to get the motion inside Blender. We go to the other tools and we have to use another file from SMPL, but this time we have to use the SMPL-X file. We have to go to the SMPL full site, go to you also have to sign in. You go to the download page, and here let me go here, download page, and you have to download the Blender add-on, SMPL-X Blender add-on. Download this folder, that's 200 megabytes. And after that, you go to the preferences. I forgot the spot. You install that add-on, which I have here. SMPL-X Blender add-on. Install it, and it's going to show another option here. Enable it, and fine. You go to SMPL-X. This is needed for you to have the model to use to import the motion. That's extremely important. I'd like to select the neutral one and press add. After pressing add, you just need to export it. Export to FBX. Choose the place that you want to. I'm gonna place it on test and select it. It's also important. This is a neutral. You write neutral. This is the first thing that must be written on the name of the file, and you can put more stuff after the neutral. So I'm gonna write as neutral v1. I think I already have one that, so I'll put v2. export this, and that's fine. Oh, it is exporting at the moment. I think it's done. It finished. So I'm gonna create a new. I'm gonna clean the screen again. Now we're going to Mocap Import, Other Tools, select that FBX that we just exported. This one, Neutral V2, get, and go to the folder that you just did the triangulation, which is test, setting, output, SMPL, and import data. It's gonna take a while, not too much because we don't have too much data. And it just imported. Oh, it looks, it's not the best, but it's not the best, but it's better than I thought. I'm gonna press this I to hide the bones. It's not the worst. Well, you can see how you can do all the process here from start to finish to get the movement. Maybe we can do a better calibration to get a better movement, but I think this one is, it's not the worst. You can do more tests and see what works better for you. I can say that now, after 40 minutes, we have this total workflow finished. If you want to stop watch, that's cool. If you want to keep watching, now I'm gonna show how to fix that intrinsic calibration problem that showed, that we can see here on this distortion. You can see that it's, no, let's go to this fixing. You can see that this is on the second camera. The first camera is here, the second camera is the bottom one, and this second camera, there is a problem. So we're going there. Let me get out of this folder. Let me go to that blend file that we just saved, that has all the options we already set. And let me go to the intrinsic calibration. I'm gonna put the camera 2 on load on VSE. Great. What I'm gonna do is I'm gonna select more frames here. Got this frame, this other corner frame, and this corner. Let me select more stuff on this lower part that I think was the problem with the calibration. I'm gonna select this one, and this one, this one, this, and I think it's good enough. Render frames, and detect chessboard again, so it can create the detection on all these frames. And now we see that it finished. Now we press calibrate. We did the calibration, save in profile, and now we're going to go to the last part. Let me close this, go to the finalize video. What I'm gonna do is I'm gonna clear all annotation, OpenPose, and image. I need to do that. No, I don't need to do that. Forget. Let's go to the Triangulate. And I'm gonna press triangulate because I already have new information of the intrinsic calibration, and I'll press here with the render raw and render triangulate point data to see how it goes. And let's do the triangulation again, which we can already take a look how it's detecting the image. And you can see now, look, now there is no distortion on the image because we selected more points, more frames, and the script had more information on how to detect the distortion of the lens. So it undistorted it, and usually you get even better detection when you do a great intrinsic calibration. Well, let me just let this finish to show the result, but I don't think it's gonna change much from what we already had. But you would have problems if your motion was happening on that part of the screen that was distorted. If you had motion around here, you probably would have lots of detection problem and probably would also have error. Sometimes when you press triangulate, it throws an error because it can triangulate the data from the both cameras. So let's see again, and let me clean. Go to the mocap, go to tools. I'm gonna get the neutral FBX, import the SMPL from the folder we just did it again. Import the data, and let's see how it goes. And interesting, it's worse than before. Let me go back and let me see the extrinsic calibration. It's fine. The cube here is fine, but the cube here is very odd. Let me try to calibrate it again. Let me do another thing. I'm going to calibrate the first one. I calibrated the second one manually, the extrinsic. I'm going to do it for the first one manually too, to see if it gets better. Extrinsic image, select. I'm going to zoom it to 200. Find the chessboard here. Create polygons, start from this part as explained before, and keep following the pattern. Okay, and save it. Save here. Let's, on the fix JSON, go to the camera one and press fix JSON. Now we copied what we've done on label me and paste it on the original file. Press the calibrate. Let's check the cross again. Cross looks fine. The cube looks fine here. Oh, you can see here the cube looks much better. It makes much more sense. Now what we're gonna do is go to the finalize and do the triangulation again. Now using the information that we just rearranged from the extrinsic camera, we fixed the first camera. it's finishing. Let me go to the screen to see how it detected. You can see now it's detected much better as it was before. You see, most of problems that you have probably is due to intrinsic calibration or the extrinsic calibration. With the intrinsic calibration, usually you fix that selecting more frames from the video that you did the chessboard recording. Try to record a video to the intrinsic calibration, recording all the corners of the camera. That's very important. Okay, it finished. Let's see the SMPL image. I guess it's gonna be good. No, it's not good. That's very odd. Sometimes it doesn't look good here, but the result is good. So let's see the result. I'm gonna clean the scene, go to the mocap, all the tools, and test. No, sorry, I have to select the neutral here. And now select the SMPL folder. Oh, yeah, I already have it here. Import data. And here we have, great. Oh man, now it's much better than the last two that we've done. So you see how important is the extrinsic and the intrinsic calibration. Let me hide the bones. Look, this is great, man. This is awesome. Great, amazing. But you see here that it's on the right direction and you have no problem here. But usually when you are doing the calibration, sometimes you put the chessboard on the floor facing upwards. In this case, my chessboard was facing up to the front of the camera. So if you have a problem on the orientation, usually what you have to do is select the bones, go to the pose mode, select the root bone, and rotate it on the x-axis 90 degrees. Usually that solves the problem. And another problem that you might have is when you got a recording of a movement, sometimes not all the times, that your footage of a person moving, you have the bone also move. You can see here the bone is moving. Some important thing to do is to erase this root bone movement. So select just the root bone, and on the keyframes you can see everything is selected. So you can press delete and it's gonna to remove the root bone movement, and that helps a lot. The result is much better. But just let me put it back. Rotate x 90 minus. This is great for me. It's amazing. I could finish the video now, but I got one last thing to show. The problem that bugged me a lot in the past, because it's difficult to understand what it is. Let me show you. Let me go back to the blend file that we are working on, and let me see. If I have a big messed up extrinsic calibration, we probably would get an error. Let me do another thing. Let me get another footage that I know we already have problems. Let me get the full footage. Let me see if we're going to have problems with it. Finalize camera 1, select the the other video, the original video, setting, I'm gonna get the sync one. Set, oh damn, it's not set, it's save. And second camera, set, select the second video, save. We have to save the video on the file, and oh my, I forgot, I would have to run OpenPose for everything. Damn. Let me get, I won't use this video, I'm gonna use one that I already have the OpenPose part done. Let me clean this. Mocap. I'm gonna select the, not here, SAP. Project data. I'm gonna select one that I did with the 5 camera. It's this project. Let me go to the finalize option. Camera 1 is test. I'm selecting, sorry, I'm going to select the video that I already recorded, because sorry, I think I have to do a proper setup to show this problem video. I won't do it now because I'm gonna do a big mess up. Well, thank you a lot for the attention, and hope it's helpful to you, and I'll prepare a proper video to show that big problem that I was talking. But if you do the proper intrinsic calibration, and if you do the proper extrinsic calibration, and if all the frames you're showing the character, you probably won't have a problem. Sometimes you have a problem when you got the triangulation on footage that you don't have the person on screen. That's also important too, and that was what I was going to show. But I'll prepare a better setup to show you guys. Well, that's it. After almost an hour, bye bye.